Hey everyone, so in this video, we're going to see if we can identify the optimal risky portfolio. So before we begin, we have to understand what's the Sharpe ratio, because the optimal risky portfolio is the highest value of the Sharpe ratio. And so the Sharpe ratio is like so. We can take their expected return of the asset or asset class minus the risk-free rate or the risk-free asset divided by the volatility of that asset or asset class. So along this efficient frontier, we're essentially finding the highest Sharpe ratio. And that value will be our optimal risky portfolio. So let's see if we can calculate that. So first, what we're going to need to do is we're going to need to specify a risk-free rate. So we're just going to say RF equals, and we're just going to pick a value right now, 0.025, for example, 2.5%. And you can change that later if you like to whatever the risk-free rate or the 10-year or whatever treasury that you're looking at right now. And so we have set that. Now that we need to do is we need to take our portfolios, data frame, portfolios, data frame, and we're going to look at the returns column, and we're going to just subtract that from the risk-free rate. So now we're looking at our data frame, all the returns, and we're just subtracting it from the risk-free rate. And then we can put this in a parentheses here like so. So we can isolate that value. And then we're just going to divide by the volatility. So all the portfolios, and we're going to say volatility, and we can again put this in parentheses in itself. And then, like we learned in the last video, we learned about the IDX max. So IDX min, we're going to use the IDX max now. So that we're just looking for the max index, so the max value of all these different values that we just calculated. So we can run that. 832 is the value that we have here. And then again, we can do the same thing like we did in our last video. We'll take our portfolios and we can use iLock again. And iLock is we're just going to specify the actual index, which is going to be 832. So we can take this whole value here, copy that, and we can just put it within here like so. Run that. And there we go. We found our optimal risky portfolio and different weighting classes. So we can see that these are different weightings that for these asset classes to help us obtain the optimal risky portfolio along here. Now let's actually try to plot this. So to do that, create another line here. And again, I'm going to import matplotlib, which should be already imported. So I'm going to say plt.subplots and fig size. And again, I'm just going to say 2010, like so. And plt.scatter. And I'm going to actually copy what I created up here so we can have our minimum variance portfolio as well plotted. So I'll just copy that. And then finally, we're going to plot our optimal risky portfolio. So we're going to say plt.scatter. And I forgot to add here, we're going to specify this as the optimal risky portfolio. So we'll say optimal, we'll define this as optimal risky portfolio. And we'll say optimal risky portfolio, run that so we can see that. And again, so let's go back to plotting this. So we'll say optimal risky portfolio, and we want the volatility because that's the X value, and we X-axis, and then we want the optimal risky portfolio, and this is going to be 0 for here the returns because that's the Y-axis, and I'm just going to say color equals, and the color we're going to choose here is, we'll just choose green. So run that, hopefully that works. And this should actually be fig size, not fic size. So fig size, run that, and there we go. So you can see we have our minimum variance portfolio, we have our optimal risky portfolio up here like so. And there it is. So if you like this video, please subscribe. In our next video, we're going to actually calculate our utility function and capital allocation line. So until next time, thank you.